Okay, so we've spoken about digestion in the alimentary canal. So we started at the mouth and we worked down all the way through the alimentary canal. And although we are supposed to go all the way to the anus, we only went all the way up to the small intestine because that's the last place in the alimentary canal where digestion actually takes place. So now we're going to talk about absorption. And remember that absorption talks about nutrients or whatever, chemicals, small particles, moving out of wherever they are into the bloodstream. That is absorption. Okay. If something is absorbed, we talk about it moving into the bloodstream. Okay. Now, so we're going to start at the mouth and work our way through the alimentary canal, looking at what is absorbed and where it is absorbed. So in the mouth, if you think of so I spoke last time when I did digestion, I spoke about bread and how it's slightly digested in the mouth. But as for absorption in the mouth, there is actually no absorption that takes place in the mouth. In other words, nothing is broken down into small enough bits during digestion to be absorbed. So there's no nutrient that, or monomer in any case, that moves into the bloodstream. However, some medication, now please don't associate the word drugs to be only bad, all right? Drugs just talks about medication. So some drugs are made or developed in a certain way so that when you already put them in the mouth, before they move down the alimentary canal, there already has been some absorption. For example, any kind of pill that you usually put under your tongue and allow to dissolve, there is going to be absorption in the mouth. Okay, but in terms of food, there is no absorption in the mouth in terms of nutrients then. Then, you know, from the digestion video, we chew that food, we swallow that food, when we swallow it, we push the bolus down our throat or into our throat, into our pharynx, and then the bolus will move down the esophagus and it will travel through peristalsis. In the pharynx and the esophagus, there is also no absorption taking place. So we know that there's peristalsis, there is movement of this bolus, but there is no absorption of nutrients taking place in the esophagus. So the next place where the bolus travels is into the stomach. Now in the stomach, there is absorption of water, mineral salts, alcohol, and as it says there, negligible amounts of glucose. Please, 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 negligible amounts of glucose. Says it is so little that we don't consider it. Okay, so basically the only nutrients that are passed in the absorbed in the stomach is water and minerals and alcohol, right? So those are things that have not come from digestion. We have not broken those down. Okay, maybe the minerals, but those are contents that are absorbed regardless of digestion taking place. Okay, so we don't really assess the stomach as or look at it as a absorptive organ. Okay, what I need you to know is the small intestine and the large intestine are so important for absorption. Right, so I'm just going to take you through a reminder quickly of the small intestine, and I'm not going to go back. I'm just going to point to this diagram over here. You will remember that we said that the small intestine is made up of all these folds, and each fold is called one villus and many villi. And when we look at the villi, we know that the villi is structured in such a way to allow digestion and absorption to occur. If you recall from my previous lesson, I said to you, there are certain adaptations of the villus that allow for absorption, and there are certain adaptations that allow for digestion. All right, so we've done the digestion one. So I'm just going to look at absorption quickly. The first thing when we look at a villi or a villus of the small intestine, the entire small intestine, so not one villus, the whole small intestine. If I had to cut out your small intestine and unravel it, it would be about 7 meters long. So if I unraveled all those, first of all, your guts inside of your abdomen, first of all, if I unravel that, that's going to be quite long. But then if I unraveled all these folds, each villi, I'm going to get to about 7 meters. And so that length aids or helps with absorption in the sense that if it's longer, there's going to be more absorption. A shorter small intestine is going to allow for less absorption. That's just the same as a bigger swimming pool allows for more water. So in this case, a larger small intestine or a long small intestine allows for maximum absorption. Okay. Chyme also passes through the small intestine quite slowly. We're not calling it acid chyme anymore, by the way, because remember in the small intestine we had the succus entericus and the bile that was and the mucus that was neutralizing the acid. So now it's just chyme. But it passes through the small intestine quite slowly. And so if you think of something that's going through time, if you think of a sponge that you just place, I don't know, on a let's say, for example, I've messed water on the floor. If I put a sponge with absorptive properties into that puddle and I leave it for a short amount of time, it's going to absorb less water than the same sponge that's left for a longer amount of time. So if the chyme is passing through slowly, it allows for more absorption to occur. All right, the next one, and I've said this before and I'm going to say it until I'm blue in the face. If there are folds, if there are villi, it increases the surface area. If there is an increased surface area, it's going to maximize the absorption. It's going to allow for more absorption. Okay. Then the next point there speaks about the villus that is supplied with blood vessels, which carry away absorbed food. If the small intestine didn't have blood vessels, then the nutrients that are digested or the nutrients that are released during digestion have nowhere to go. We need them to get somewhere to go. There is no point of diffusion or osmosis having to happen all the way from our small intestine to our heart. That would be sort of arbitrary. It wouldn't work. So we need to supply the small intestine with a good source of blood vessels so that the nutrients that have been released can be absorbed into the blood. So if you look at this diagram, you'll see that there are arteries and veins that join as a capillary network. And you know that arteries, remember arteries away, so arteries come away from the heart to the small intestine, and then a vein goes to the heart. So in this case, the arteries are bringing blood to the small intestine for the small intestine to be able to do its purpose, right? The small intestine needs a supply of oxygen. And then the veins are there to carry the nutrients technically to the heart, but remember, we're going to do it via the hepatic portal vein. Okay, so, but the main adaptation is that the villus are supplied with blood vessels to carry away the absorbed nutrients. The fourth bullet point there talks about columnar epithelium. Now, you did columnar epithelium in grade 10, so I'm not going to go over that much, but it's lined by columnar epithelium, and those columnar epithelium have what are called microvilli. And think about this, it's like a fold upon a fold. So those microvilli are technically like little hairs, they appear to be little hairs, but they increase the surface area. They are increased folds. So the minute we know microvilli or villi, we're going to say increased surface area. What is increased surface area going to do? Maximize absorption. The next bullet point talks about goblet cells. Now again, you learned about goblet cells in grade 10. Goblet cells are cells that produce mucus. And so in this case, if these goblet cells are found in the epithelium, in the columnar epithelium, and they are producing mucus, then that mucus is going to keep the surface, the epithelium, moist. Hate that word. If it is keeping the epithelium moist, then it's going to aid in absorption. Think about this, guys. A dry surface takes longer to absorb than a wet surface. Now, that sounds strange, but think about this. And I like to give this example. I'm sure you've seen that advert. I don't watch TV. I only watch Netflix, so I don't see ads. So I don't know if it still shows. But there used to once upon a time be this ad. I don't know if it was for Nivea or for Vaseline or for whatever, but for a cream. And the gogo would tell her grandchild that her legs are ashy. In other words, very dry. And then if you put this cream on, then eventually it's a miracle cream, and then you have nice, healthy, moisturized legs. Okay. If you think of your winter legs, most of us, especially women, don't want to apply cream in winter because it's cold. And so our skin cells become dried out. They're not getting moisture. They're not getting this moisturizer, the nutrients from moisturizer. And so our cells become more dry. Okay? Think about if your cells are dry. It takes a few times putting on cream to get your legs back to that good condition. So in other words, they're absorbing more slowly than they used to. Whereas if your legs are already nice and moisturized, or your skin is nice and moisturized, then it stays moisturized because it's absorbing more efficiently. Okay, so a moist surface, a moisturized surface is going to absorb more than a dry and barren surface. So in this case, the goblet cells that are producing the mucus are keeping the surface moist so that it can maximize absorption. I hope that makes sense. And then the last bullet point here, and don't get too excited, it carries on the next slide, I think. Maybe I'm wrong. That columnar epithelium that lines the small intestine is only one layer thick. Okay, so there's not layers upon layer of columnar epithelium. There's only one layer in total. And the reason for that is if we have, say, layer upon layer, so we have 4 layers of tissue or 4 layers of cells making up tissue, then whatever needs to diffuse from one side, the inside of the small intestine, to the outside, for example, where the blood vessels are. So let's look at this white space, right? Let's say the nutrients are all sitting in this white space. They need to essentially end up in this capillary network, right? So if we had 4 layers of epithelium, they would have quite a barrier to move through. And we don't want that. We want them to be able to absorb through the cells into the bloodstream more easily. And so we only have 1 layer of epithelium making up the lining of the small intestine. And that's going to make absorption so much easier. Then we have this structure over here. And when I did the structure of the small intestine, I spoke about this. The structure that runs in the middle here is called a lacteal. Now, the lacteal leads to the lymphatic system. The lacteal is going to transport the lipids, the fatty acids and glycerol, away from the small intestine. And it's not going to take it to the heart. It's going to take it to the lymphatic system, because we get rid of fats differently than we do with nutrients, because we obviously don't want to be pumping all this fat to the heart. So although we need a good amount of fats in our diet, we're not transporting them into our bloodstream. We don't want clogged arteries and veins. Okay, then the second last one. The lining of the small intestine is made up of smooth muscle. And that smooth muscle keeps the lining or the small intestine in contact with the food. So in other words, the tissue, the muscle tissue of the small intestine is always touching the food that is being digested, so that there's direct contact so that absorption can occur. So it's not like the stuff that is being absorbed is far away from where it needs to be absorbed. And then the last one, in the small intestine, there are little like glands. Now, I haven't shown you one because we haven't had one in the diagram, but sometimes say in the folds, there'll be this extra little thing. It looks like an inward pimple called a Brunner's gland. You will never have to label or know where it is or whatever, but it's basically a gland within the small intestine. These Brunner's glands, they secrete mucus as well. And what that mucus helps to do is also to neutralize the acid chyme. And we know that that's important because the small intestine, the lining, the epithelium, can't withstand the acid from the stomach. Right, so those are all your adaptations of the small intestine that help with absorption. Now, I told you in the last lesson to know a few that aid in digestion, know a few that aid in absorption, so that you can answer this question well. And hint, hint, nudge, nudge. This is a nice question for tests and exams, to name the adaptations of the small intestine. Because, and please, if you repeat this, I will kill you. But basically, it doesn't matter if you understand it or not. If you have learned a lacteal transports fats and lipids away from the small intestine, if you have no idea what that means, so if you walked up to, I don't know, your friend who doesn't do bio, and you said, a lacteal transports away lipids from the small intestine, even if that sounds like Greek to them, they learn it like that and they write, and that's it. That's the answer. Okay. It doesn't matter if you don't understand it. It's like if someone tells me that this in their language, hello means, or hello is whatever. It doesn't matter if they speak the language. If I recognize that word, even if I don't understand their language, I recognize that word. I know what they're saying. Okay, so what I'm saying by that is this is a nice question in a test, because even if you didn't understand quite what I was saying, which I would hope that I'm explain it in a way that you do understand, but even if you didn't, then if you just parrot fashioned this, that's some nice marks in a test or in an exam. All right, moving on. So in the small intestine, now remember that the small intestine was the final port of digestion, right? So everything was broken up into its most basic monomer in the small intestine. So by the time we got to the end of the small intestine, we now had carbohydrates broken into glucose. We had proteins broken up into amino acids, and we had our fats broken into 3 fatty acids and a glycerol. So everything is now in its monomer form. Now we need to absorb those nutrients, and those nutrients need to go where they need to go. So if we look at amino acids and glucose, so the monomers of proteins and carbohydrates, they are going to be absorbed by diffusion into the bloodstream, right? Into the blood vessels, the capillaries that I spoke about, through the villi. And they will then those nutrients need to be transported basically to the heart. But they're not sent directly to the heart, because you must understand that, and we'll talk about this especially when we do excretion, but basically any particle that is small enough to be diffused will diffuse. So if there are particles that are dangerous or toxic or whatever the case may be, they are also passed through. So we do not want to have diffusion of these toxic things or these bad poisonous substances, and then they go straight to the heart, and then the heart filters them all around the body. That would be stupid. So there is no vein leading from the gut, the small intestine, and the stomach, all the way to the heart. It first has to go through, it has to go through customs, right? So it's coming from another country, and we need to sniff it for drugs first. So what happens is it goes from the small intestine to the liver. So technically, the small intestine is the other country, the liver is the airport, the customs at the airport, and the heart is the country that they want to go to. So basically, they go from the country that they came from, they get sniffed for drugs and bad things in the liver, and they may only pass to the heart if they don't contain the drugs. The oaks that are bad are detained by the liver, and only the good people can go, or the good people can go to the heart then, right? So the liver is going to assess what it needs to get rid of, detoxify, and what can be then filtered through to the heart. All right, so because it doesn't go directly to the heart, we say that it travels through what's called a hepatic portal vein. Now, the word hepatic says liver. Portal is exactly like you know it from all the series that you watch. A portal, right? A thing that travels you from one place to another. And obviously vein says in a vein. So it's a portal, it's a channel that takes you from one place to the other through the liver in a vein. Okay, so that's your hepatic portal vein. Glucose and amino acids travel via the hepatic portal vein to the heart. The fatty acids and glycerol that were broken down by fats or through fats are absorbed by the lacteal. Remember, there was the lacteal in the villus. And inside the villus, inside the lacteal, there is also a liquid, and that liquid is called chyle. Chyle with a l, not m. Okay? This chyle is made up of fatty acids and glycerol and the stuff within the lacteal. And this is transported through the lymphatic system. The lymphatic system will then monitor how much of this chyle is transported into the bloodstream or not. We are not going to do that in detail. I just want you to know that what a lacteal transports. All right. And then vitamins. Remember, we'll also be breaking down, when we're breaking down this food through digestion, we're also going to release the minerals and vitamins that were found in these food groups. So the vitamins are going to be passively absorbed into the bloodstream. What does that mean? It means it doesn't require energy. We don't need ATP. Vitamins will move through the act of diffusion into the bloodstream. Minerals, however, because they are large compounds or larger substrates, they need to be actively absorbed into the bloodstream. In other words, we need to use ATP energy to transport them. Okay, at the end of that, I want to say, now we have, let's say, we now have our small intestine. Inside our small intestine, we had the chyme. The chyme is made up of all the monomers, as well as water and fiber and whatever else. We now want to remove the good things, okay, or not only the good things, that's not the only stuff that is removed, but we want to remove what we can, or what can be removed will be removed through absorption, okay. So in other words, the end of the small intestine, I'm going to say bye-bye to glucose and bye-bye to amino acids and bye-bye to glycerol and bye-bye to fatty acids and bye-bye to vitamins and bye-bye to minerals, right? All those things are going to be removed out of the chyme into the bloodstream. But I still have stuff left in the small intestine. That stuff, in this case, is mostly water and fiber, all right? So that water and fiber is now going to enter the large intestine. Now, your large intestine, I showed you this in the previous, when I did the digestive system, but your small intestine sort of falls in the middle of the large intestine here. It links up over here to the large intestine, okay? The large intestine, it then travels up, ascending, up, ascend, transverse, across, and descending, down. It then moves from the descending colon into the rectum and the anus, okay? When digestion has happened and absorption has happened here in the small intestine that you are not seeing here, then whatever's left after I've said bye-bye to all those things, they're going to enter the large intestine. So I said that's mostly water and fiber. That is going to move up and across and down the large intestine. I would hope that you don't enjoy to have diarrhea. I don't think anybody does. So we absorb water. We need water, right? We need to get the water that we need as a nutrient from this kind of digestion. When we drink water, some of us have the misconception that water is filtered through our urine. And yes, it's involved there, but we'll talk about that at a later stage. Okay, but the water that we're getting is still coming from digestion. So when this water and this bulk, in any case this fiber, is traveling in our large intestine, the water is absorbed into the bloodstream. So what did I say absorb means? It moves from an organ through diffusion into the blood. So water is going to leave the large intestine and enter the bloodstream. So essentially I want you guys to imagine a stocking, all right? Yeah, it's not tights, not thick tights like you those ones with no pores. I'm talking about those stockings like the old ladies wear. If you imagine a stocking like that, and you imagine that in a Tupperware bowl, I mix up, let's say for example, I break bread into small particles, and I add some water, and I add some, mush of different foods, okay? If I make it a watery mush, so there's a mixture of water and juices, as well as mushy stuff. Let's say like potatoes and bread mashed up. If you imagine that I put this stuff into that stocking, and I push onto that stocking, what's small enough to fit through the holes, through the pores of that stocking are going to. So I'm going to get some mush coming through those holes. Those would be the nutrients, okay, that's being absorbed in the small intestine. But I'm also going to have some liquid come out, okay. If I've then gotten rid of whatever mush, and at the end of the stocking, I then take that stocking and I roll it in a towel. I'm going to find that the towel afterwards is wet, because more water as I roll, imagine like rolling a bread pin. As I roll that stocking in the towel, more and more water is going to be absorbed by the towel. The towel is going to end up wet. That is the function of the large intestine, is removing the excess water from this mixture. Okay, so that at the end of the large intestine, all I'm left over with, is mush. That mush is what is made up mostly of fiber. And remember, right at the beginning of me starting this topic, I said fiber makes up the bulk of feces. We need fiber in our diet to have, essentially, being as graphic as I can be, a good turd. Right? We need some fiber so that we have a nice stool to pass into the toilet. Now, I don't know that you've ever described your stool as nice, but you all know that some poop is better than others. You know that you get your nice ones, and again, graphicness, but no one discusses these things in real life, so I might as well, and I don't have to face you, that's the best part. But you get what's called an S-shaped poop. That basically, it's the perfect shape, it's got the perfect consistency of bulk, of fiber, and it comes out smooth and easy without any kind of struggle. And when it does, and you wipe, essentially there's almost nothing to wipe because it's come out so perfectly, right? Lots of times, oftentimes in any case, it is so perfect that it just disappears. You don't even see it in the toilet bowl. Other times, you end up with this freaking turd that you wipe and wipe and wipe 7,000 times away, and it still feels like you probably need to take a good bath because of the consistency, the stickiness of that feces. That means you didn't get the right amount of fiber in your diet in that particular time. Then obviously you get diarrhea. Diarrhea obviously is your watery stool. That means that your large intestine did not function properly. Okay, so often what happens is when we eat, if there is something bad, if there is something off in that food, something that our body wants to flush quicker than the liver can, then our body goes into a mode where it sends it so quickly through the small intestine and large intestine. No absorption is going to happen. We're essentially losing the nutrients of the food that we ate because no absorption is happening in the small intestine. No absorption is happening in the large intestine. So in other words, no water is being removed from what we've digested, and therefore we end up with this diarrhea. Again, this graphic teacher who you are laughing at on the other side of your screen, often diarrhea bubbles. Okay, diarrhea smells, diarrhea bubbles. It kind of looks like volcanic eruption in the toilets. And that is because, essentially, think about it. Whatever broke down in the stomach, whatever was digested in the stomach, has passed very quickly through the small intestine and large intestine. And so you're actually ending up with acid chyme in the toilet bowl. Right, and again, the wateriness of diarrhea is because no water was absorbed in the large intestine. On the other end of the spectrum, you have constipation. Now, constipation means that too much water was absorbed. So often constipation comes in with food where the type of food was moving way too slowly through the large intestine, meaning most of the water was absorbed. Or often there's a fold or something happening in our large intestine that causes sort of food not to be able to travel properly and get stuck. And then all the water is absorbed from that food. And essentially we have this food that doesn't have anywhere to go because it doesn't have the moisture to travel anymore. And that is what causes constipation. Now, you won't be tested on diarrhea and constipation other than maybe understanding the logic of it. But I don't think that any of you sit at the dinner table or the in front of the TV and ask your parents about their S-shaped poop or their diarrhea or their constipation, or it's kind of like one of those topics we just don't discuss with people. Well, I hope so. If you discuss it with people, there might be something wrong with you. But so I'm discussing it with you because it's interesting, and like we all go to the toilet. Everybody shits. Like there's no difference between you or me. We all do it, so we might as well understand what's going on when we do it. So I hope maybe some of you are like, oh, okay, that makes sense. Cool, thanks, ma'am, for that disgusting bit of information that I probably didn't need in my life. But next time I have diarrhea, I'll understand why that happened. Anyway, okay, so where we're at now, we have now absorbed water from the large intestine, and we are left with this fiber. That fiber will then pass through the rectum, through the anus, and then into the toilet. Okay, so that's digestion and absorption completed. Right. And so that is the end of this lesson, and I will be finishing off the topic in the next lesson.